Hello. If you are comfortable with the Claisen condensation, fill in the products and mechanism problems, then you are ready to do synthesis where you're given a target molecule and you are asked to propose a synthesis here using Claisen condensation to make that target. Let us take a look at the first one. The strategy here is to understand which carbon-carbon bond was made. It's also to understand that you made this via a Claisen condensation. Remember, Claisen condensations, you typically get what's called a beta keto ester. And so find your ester, which is right here, right? This is the ester part. And here's your alpha, and here's your beta. So that's a good sign that this molecule was made via a Claisen condensation. If you recall, for aldols and Claisens, the alpha carbon did the attacking of the carbonyl group of another molecule or another part of the molecule. So my guess is that this alpha carbon and this carbon here, that was the new bond. And in the Claisen condensation, that is true, that it would be the bond between the alpha and the beta. So those are our two parts of the molecule. If you've seen my videos in the past about aldol and Claisen, you might have heard me say that when you draw the product, draw the attacker as is, meaning that at the end of the mechanism, the part of the molecule that was doing the attacking looks identical to what it looked like at the beginning. And so if this is the part of the molecule that did the attacking, the one with the alpha, and I drew that exactly the way it looks like in the starter material, then you would predict that the starter material looks like this. And here's your alpha. Now, for a Claisen condensation, you have to make the enolate. So to make the enolate, again, you want, if you saw my previous video on Claisen, you want to match the oxide base with the leaving group. So you could say ET for ethyl, or you could draw that. I'm trying to match this part to this part. That explanation is in the previous video, or a previous video on Claisen condensation. Why do we have to match the R group of the base with the R group of the leaving group? But also, you want to show that you know what the solvent would be. The solvent would be as if the base was protonated to make the alcohol. For a Claisen condensation, you also have a second step that's acid. That's because in the process of making the product, since you are in basic conditions, like look at this product here, right? That hydrogen is in between two acyl groups. So it's very easy to deprotonate because you have resonance on both sides. Or you could put the negative charge on either one of these oxygens when you draw the resonance. So that hydrogen was ripped off during the reaction. You have to replace that hydrogen with acid. Now the question is, before we move on, is this part here, the one that was attacked, the same molecule as this? Okay, this is the answer, by the way, but you could prove it because in scratch work, if you have this same molecule, and I'll draw it regularly like this, well, yeah, your alpha carbon is attached to this carbon here, and you are kicking out the leaving group. And so wouldn't that piece that's left over, this piece right here, look exactly like this piece? So you could try it yourself, or you could test it out on a classmate. Say, hey, classmate, this is my answer right here in blue to make this molecule. Oh, don't tell them what molecule to try to make. Say, if I give you this reaction, what would your product be? And if it matches this, then you're good to go. Okay? So again, you could ask a classmate, draw me the product of the reaction that I'm proposing. So this is, in medium blue, this is the answer for part A. Look what we did for part A, okay? Before we started drawing our answer, we did our analysis, right? Our ester now is here. So this is our alpha, this is our beta, okay? And the bond that was made was right here. So this one's a kind of an interesting dilemma, because it looks like, when I cut here, I have two pieces. And that is easy to see that one piece became the enolate and attacked the other piece to make the target molecule. But when I cut here, I don't have two molecules. I have one molecule that's still connected. Okay? The thing is, you got to remember, what did you attack? In the first case, right, this carbon was attached to this carbonyl, and actually it was an ester, right, because we kicked out the leaving group. So you are attacking an ester, right? So you got to remind yourself for this one, even if we do the cut, like literally, if we cut right here, that's not the answer, because you got to remember the Claisen is you attack an ester. You attack an ester. So this part has to look like an ester as well. So keep that in mind. For this molecule B, I would start out drawing the ester part. Okay, I'm trying to keep it all on the screen. And I'm going to draw it in the same shape, but don't draw the carbon-carbon bond that was made. Okay? And so the thing is, you get to pick what ester you put here, but the best answer is the one that matches. Do you see how, well, obviously this matches this because it's the same molecule, but also this matches that. So here's a clue, here's an ester. It would be ridiculous to make this an ethyl ester. It should be a methyl ester right here. And so I'm going to draw it, there's not much room, but I'm going to draw OCH3. That would show me, or that would show the grader that I know that this alpha carbon will eventually attack this carbon here and kick out the leaving group. Okay? If you want to draw it neater, this is an example of a intramolecular. So one way to draw this is the following. Okay, how many carbons? 1, 2, 3, 4, and then the dimethyl. 1, 2, 3, 4. Oh boy, and then the dimethyl. And then our ester that we attacked. Let me double check. 1, 2, 3, 4 CH2 groups. 4 CH2 groups. Okay. And then let's do a gram check. How many total carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Now this is an interesting diester because we have an alpha carbon here, but there's no alpha hydrogen. So the alpha that we're using is this one, and we're making this bond here. And you kick out this leaving group here. Okay? So that is our starter material. And yeah, the answer's in blue, but I put a lot of different notes on there in different colors. Same thing here. The answer's in blue. And so the base we want to use has to match. Let's use NaOCH3. The solvent has to match. So when that base grabs a proton, it will look like the alcohol methanol. Well, it is the alcohol methanol. And then 2, we need acid, H3O+. That is the answer for part B. Okay, and do you see what I'm doing here? One of them is a self-Claisen. So I say Claisen, technically it's Claisen condensation. The second one is a intramolecular Claisen. Okay. I think we have a cross Claisen to do for the last one. Okay. Let's do our analysis up here. Again, it's the same pattern. What do we do first for A and B? We identified the ester part. And then we found the alpha and the beta. We understood that in the reaction, the alpha carbon ultimately attached to the carbonyl. So alpha is attaching to beta in this case, in all cases. Okay, so we have two pieces. And literally, okay, I'll put it back, but literally you have these two pieces. Okay, ta-da, that's one of the pieces. That's one of the molecules. Without any change, draw the ester that attacked as is. So the starting material looks exactly like that. Now we're attacking a different molecule, okay? And remember how we had to add the ester here? We had to add OCH3. Well, we're going to have to add an ester here also. We have to make it OET to match this. So if this OET matches that OET, it's also going to match the base, NaOET, and it's going to match the solvent, ETOH. Okay? Let me put back the molecule together, and let us draw now the cross Claisen. Okay. Come with a strategy to, we call it like the disconnect strategy or the retrosynthetic strategy. What bond was made? I drew a dotted green line to show what bond was made, because those are the two pieces that came together. Cross Claisen. And our attacker was what? It was ethyl. ETO. I'm trying to memorize this. ETO. We definitely had that. And I think we had a methyl. Yeah. Right here. Okay. So I have that down here. That was alpha right here. Cross Claisen, we have a different molecule. It has to be an ester, but I saw part of it was this. Carbonyl for sure. And the ester we're going to use is OET. Ethyl ester. Let me double check. Yes. Okay. The base we're going to use, we're going to match NaOET. The solvent is going to be ETOH. It matches again the R group. And let's use HCl, H2O2, put back the hydrogen. That's the answer for that. And if you really want to do the analysis like we've done in the past, you're having this connect, and then you're kicking out, again, the leaving group. So I'm looking at this, that. We've done exactly the same thing here as well. And we've done exactly the same thing here as well. Mark the alpha, draw the green dotted arrow, and then circle to remind yourself what you're going to kick out, what leaving group you're going to kick out. Okay. On the actual exam or assessment, don't go too crazy with all these annotations. The answers are in blue. Okay, the answers are in blue.